Okay, today we're going to be looking at problem number 29 and 30 on page 383 from chapter 7. This is going to tell us a little bit about expected value. We can use calculator when we get one of these tables to find the expected value and standard deviation more quickly. What I can do is I can go to stat edit like I just did, and if you've already got data there, you can highlight L1, press clear, enter, and that gets rid of it. I'll do the same thing, highlight L2, clear, enter, and that'll clear out any existing data you have. And now I'm just going to type in the data it gives me in the book as my Y values are going to go in L1 and my probabilities are going to go in L2. You always want your raw data in L1 and your probability in L2 when you're setting up one of these problems. Now the formula we have for expected value is that I take the mean of a random variable and the mean of a random variable is just a synonym for expected value. The formula is to take the sum of the x values times the probability of those x values. So that is the formula we're going to be using for the mean or expected value of a random variable. And then a second formula we have for the variance of a random variable is that once I have that mean, I'm going to take all my deviations by getting x minus my mean. That's going to be my deviations. I'm going to square those deviations just like I do with standard deviation and multiply it by the probabilities. So those are the two formulas we're going to be using. They're both found on your formula sheet, but you can write them down at this time if you'd like. Now to continue with this, since my formula said to multiply the x values and the probability, what I'm going to do is I'm going to go up to L3 and I'm going to tell it to take the x values, which are in L1. I can just do second number 1 to get that, times the probabilities, which are in L2. I press enter, and then that basically has multiplied all my x values times my probabilities. Once I've done that, if I want this, what I can do is I can find the sum of a random, I can just find the sum by doing stat, calculate 1 var stats, and that will give me the sum. You do need to tell it which list to do. When you're under 1 var stats, you need to make sure it says L3. If it doesn't, you can do second L3. Then what I can do is I can just press enter a few times, and then what I'm looking for is the sum. So the sum of my expected value would be 0.56, as you can see right here is your expected value or mean of your random variable, 0.56. Once you have that, you're ready to go on. The next question it asks for part B is what percentage of the cartons is less than this? Well, if I go back to stat edit, I'm looking for values that are less than 0.56. So the value that is less than 0.56 would be this value here. And so I've got a 65% chance of being less than 0.56. Now, it asks if that surprises us. I'm not surprised a lot, but you may be, because you might have expected it to be exactly 50% under the mean, but there's no guarantee that these probability distributions are symmetric, so that means that the mean of the distribution won't necessarily, it's the balancing point, so it won't necessarily be equal to the median. The median would cut off exactly 50%, but the mean will be fine. Okay, the third part of this question, part C, just asks about why you can't just add them up and divide by 5 to get the mean. The short answer of that is if you look at your probability distribution, they are not equally likely to occur. Therefore, since some values are more likely to occur than others, you have to, these probabilities basically make it a weighted average, so you have to be involved on which average is. You cannot just add them up and divide them by 5 because that would assume they were all equal. For number 30, it wants to know the value of unbroken eggs. Well, that one is pretty straightforward. If the number of broken eggs is 0.56, if you were looking for the number of unbroken eggs, what you would need to do is the total number of eggs, which if you're buying a dozen eggs, that would be 12 minus the 0.56. So that is all you would have to do to find that new mean value. So it would be 11.44. So that is a brief explanation of number 29 and 30. I'm going to go ahead and do one more thing, just since we have this data in here for a teachable moment. I'm going to go ahead and work on the standard deviation of this random variable as well. If I wanted to go ahead and do standard deviation of the random variable, I'd go to Stat Edit, I'd go to L4, and I need to get my deviations. So my deviations are my x values minus the mean, which is 0.56. I'm closing that up, and I'm going to do a square because I have to square those deviations. So I take my square deviations and multiply them by the probabilities, and that would be the different numbers you would need. Once again, I would need to add those up. So I can do stat, calculate 1 var stats, and this time do it on L4, and that's going to give me the answer I need. Once again, I'm just looking for the sum. So the sum would be the 0.8064. Now the sum of those values, that's the variance of my random variable. To turn it into a standard deviation, I would go to the main screen of the calculator and take the square root of that number. So the square root of 0.8064 is going to be equal to that for your standard deviation. That's how I could also find standard deviation of a random variable.